Hello friends, I am Sound Paper and I welcome you all for the third lecture series of assignment problem. So today we are going to discuss about a special case which includes a maximization type of problem along with a multiple solution. So let's start how to solve this kind of problem. So as you can see, a problem is given with the given data. You can see these are the different district and these are the different salesperson. So these are the profit that can be obtained by salesperson for particular district. Say this salesman one has obtained, and these values are assumed to be in thousands. So this salesman have come with the revenue of 40,000 in district one. Okay, so likewise these are the profit values that has been obtained by each salesman district wise. Okay. So, as we know, the assignment algorithm, similar to transportation algorithm, is useful to obtain a minimum value. So that will return a minimum value when you apply this algorithm. So when we have to face this kind of maximization type problem, the first step is we need to convert this into minimization type. So for that, as we have already done in case of transportation problem, first of all, we need to find out the maximum value from this matrix. So as you can observe, the maximum value available with us is 49. So we will subtract this 49 from each element available in this matrix, and that will return us opportunity loss matrix. Okay, so that is one way. Another way is to multiply all this value with -1, and to proceed with that minus value will be bit confusing, so we are avoiding that route. Instead of that, we taking this route of opportunity loss matrix. Okay, so here we are going to subtract all this value from 49, and that will be opportunity loss, means 49 minus 49 will be 0. So that is the maximum 0 and there is a no loss of opportunity here. But if we consider this case, so out of 49, if we reduce 40, this will be 9. So that is the loss of opportunity we have here. Okay, so next table, when we proceed with that subtracting all this cell, and this is our opportunity loss matrix available with us. So here you can observe all the values are subtracted from the 49, and that will indicate a opportunity loss matrix. So minimizing this loss will be our interest, and that will be in turn increase our profit. Okay, so we proceed with this way. So similar to our assignment algorithm, we will start from with this table. So first step is to get a reduced cost table by row minima. So the minimum value in this row is 1. So we'll subtract 1 from each cell available in this row. So this will become 8, this will be 2, this will be 0, this will be 12, and this will be 0. Now for the next row, similar. The minimum value available in this second row is 1. So we'll reduce this 1 from each element of second row. So this will be 0, 16, 12, 19, 4. Similar for the third row, the minimum value available with us is 0. So this 0, when we subtract, the row will remain unchanged. For the next row, again we have 0. So this row will again remain unchanged. For this fifth row, we have minimum value 1. So we'll subtracting 1 from each element, and here we have reduced cost table 1. Now we proceed for the second step, that is to subtract a minimum value from each column. So for this column, minimum value is 0, so this will remain unchanged. For this second column, the minimum value we have is 2, so that we are going to subtract from each column cell. So this will be 0, this will be 14, this will be 12, and this will be 1, and this will be 5. Similar for the third column, minimum value we have 0, so this will remain unchanged. Fourth column, minimum value we have is 5, so when we subtract 5, this will become 7, this will become 14, and this will become 6, this 0, and this 0. For the fifth column, minimum value we have is 0, so it will remain unchanged. Okay, now we will proceed for third step, that is to draw a number of lines which will cover maximum number of 0. So we'll draw a line in such a way that will cover maximum number of 0. So here I can see the 3 zeros in single row. The next line we can have is this one, this one, and this one. So number of line we calculate 1, 2, 3, and 4. So again the number of line are not equal to the matrix. The matrix is small n equal to 5 because the matrix is equal to n 5 by 5. So now we need to modify this matrix, and for that we are required to reduce a list value from uncovered cell. So uncovered cell having a minimum value is 4. So we are going to subtract this 4 from all uncovered value and going to add this 4 at junction. At junction means where two lines or more than two lines have been met. Okay, so here we are going to add 4, at here we are going to add 4, and at this point remaining all value under the line will be unchanged. Clear? So proceed with this change. So this 4 will be 0, this will be 10, 12 minus 4 equal to 8, 14 minus 4 equal to 10, this will be 8, this will be 4, this will be 2, this will be 0. Now at junction point this 8 will become 12, 19 plus 4 that will be 23, 11 plus 4 that will be 15. Okay, now we will proceed for the next step, that is to draw a number of lines again. Okay, so now we are going to draw a number of lines again which will cover maximum number of 0. So here the number of zeros available with us is here 30. Next line we can proceed is this one. Next available line you can go here or here and here. So the number of lines we can made here is 5, you can observe. So the number of lines are matching with the n value, that is matrix value. So now we can proceed for the further solution, that is next step. So condition of number of lines are matching now. So we can now make the allocation with the list number of 0 available in each row. So now let's check in which row we have minimum number of 0. In this row we have 3 0, so no allocation can be made here. in this row 2 0, in this 2 0, here 2 0, here 2 0. So we don't have any single row with a minimum number of 0, means a single 0 is not available in any row. So we can arbitrarily made allocation. Before that we also check the any column if available with single 0. Yes, this column having a single 0, so we proceed with this and making allocation over at that point and making remaining 0 in that particular column at unassigned. Okay, so in this row we cannot make further allocation. Next available allocation, you can find number of 0 are in each and every column and row are having a 2 0. So we arbitrarily going to made allocation. Say if we made allocation over here, then we cannot further proceed at this point. In this row we cannot any further allocation, and for this column also we cannot make further allocation. Clear? So now minimum number of 0 available with us is in this row we have single 0, so we can allocate over there. Next possible number of minimum 0 is if we allocated here. Now we have these two having a similar position, so arbitrarily we are going to made allocation. If over here, then you cannot make allocation over here or over here. Okay, now next possible allocation we have this one only, so we are going to allocate over here. Okay, now you can check the allocation has been completed. The number of allocation we have is 1 2 3 4 and 5, and that is our answer. So we can simply write down our answer over here, that is S1 D2. Next position we had S2 D1, then S3 D5, then S4 D3, then S5 D4. So this is our first answer that we have obtained. Okay, since we have made many allocation arbitrarily, so there are many possibility to get different answer. So this is the first answer that we have written over here, and let's check what other answer that we can get if we change allocation. Instead of choosing this 0, if I have chosen this 0, then answer would be different. Similarly over here, instead of choosing this 0, if I have allocated over here, then the answer will be again different one. So I have many choices available over here, and I will check all the possibility. So I am going to allocate all the possibility I am getting over here, and let's check the answer. What are the answer we are getting from this different allocation? So let's do it once again, starting allocating. Since this column having a minimum number of 0, so again we are going to allocate over here. So we are going to cancel out this 0. We are not going to allocate in this row further. Next available 0, in this row we have 2 0. So in last time we have allocated over here, this time we checking with this allocation. So let's allocate at this 0, and we cancel out the remaining 0 in that row and in that particular column. Okay. Next possible allocation, we have only single zero in this row since this one is cancelled out. So we can allocate over here. Okay. And the remaining zero we can cancel out. No zero available here. Now the next allocation that is possible out of this two row is again we have two choice. So last time we gone through this way, so we choosing this and cancel out this one. Okay. Now next possible allocation that we have is this one. Since this zero is cancelled out, so we have left with only this zero. Okay, so this is another possible answer that we have obtained from different combinations. So again we can write down the positions that we have obtained: s1 d2 comma s2 d5 comma s3 d1 s4 d4 and s5 d3. So that is another answer that we have obtained. Likewise, we can also further check the different possibility. In this solution again, instead of allocating this 0, if I choose this 0, then this will be cancelled out and this can be allocated over here. Okay, so again we have different combinations. So likewise we can obtain four number of combinations, since instead of using this 0, if I had chosen allocating this 0 and this 0 has been allocated, then we had fourth solution. Okay, so I think all of you have understood this multiple solutions for this case. And finally we are going to put all this allocation value in our original matrix, not in this opportunity loss matrix, but this allocation we are going to put in our original cost value, and then we will calculate the cost for each allocation, and then we'll calculate the total cost. So let's proceed with the further step. So I have noted down the all combination that we have obtained for the different allocation, and this, as per this combination, we are going to calculate the total that we can obtain from original matrix. And we have observed that the total we have obtained are same for each combinations that we have got as an answer. So this is known as a multiple solution situation. So for any kind of combinations we are getting the same answer. So there are, here we have four possible answers. So four combinations we have obtained that can result in optimum assignment. I hope it is clear to all how to solve a maximization type of assignment problem with the multiple solution. So thank you all. Don't forget to like, share and subscribe.